Hi there, this is video C22, and we are looking for combinations from several sets. Now, there was an introductory page, at least one, I think it's C21, and this particular page, the entire thing deals with cards, because that's a really common one where you're talking about choosing things from several sets. Okay, so here we go. My suggestion is give it a shot, or let's work through the first one or two examples. And then try them on your own, right? As always, it's very important that you try these on your own so that when you come to doing an assignment or some kind of an assessment, a test, quiz, or something like that, you're not going to panic because you don't know where to start. Okay. Don't know if it's picking it up, but my dog has a new toy and she's pretty excited. A game of cards is played with each person being dealt 13 cards. Okay, this might be important. Find the number of ways that each of the following hands can be dealt. Okay, so when we're talking about cards and they're talking about hands, it's almost always a combination. It says combination up there, but that's a hint when it's not labeled what type of question it is. Because when you think about it, when you're dealt these 13 cards, okay, so what's the first thing you do? You pick up your cards and then you start organizing in your hand. So the order that they were dealt to you really doesn't matter. So when order doesn't matter, then you know it's a combination. All right, let's get at this. So we're supposed to have 13 cards. So 4 diamonds, 3 clubs, and 6 hearts. Now my brain says 6 and 4 is 10 plus 3 more, 13. Okay, so I'll make sure it matches that. I don't know if it's going to get tricky later on, but I wanted to make sure I have all 13 cards. So what's the plan? You remember from before, you draw a blank for each one of our sets. So we're going to be choosing some diamonds, we're going to choose some clubs, and we're going to choose hearts. And so it's kind of starts out with fundamental counting principles. So we need 4 diamonds. Oh, and I'm going to do this because I'm lazy. Right? We're choosing. And I'm choosing 4 diamonds, right? That's where that goes. But the number in front is the number I have to choose from. How many diamonds are there in a deck of cards? Yes, there are 13. Okay, you know what? 13 clubs, and there's 13 hearts. So that's going to be the same. And now we can just throw in our numbers. So for our clubs, we're going to choose 3. And for our hearts, we're going to choose 6. And then, because I have my nice little, oh, we can see it over there. My handy dandy calculator that has my combination button on it, right? See right there. I'm just going to put this in 13, 4. And right, fundamental counting principle, I'm going to put a dot just so it looks like, or remember, I'm going to multiply times 13, choose 3, times 13, choose 6. Well, I was going to say, and these card questions tend to have really big answers. So 3, 5, 0, 0, 904, 840. So 350,904,840 different ways that can happen. Ta-da! All right. This question's almost exactly the same. So if you haven't paused it, you should. So 1, 2, 3, 4. We got to pick some kings, some queens, some 7s, and some 2s. So king, queen, 7, 2s. I'm putting that in there so that later on, if someone just looks at the answer key, they'll know what's going on. Always good to show your work, or if you go and look at it later. So I need 3 kings. I'm going to choose 3 kings. But this time, how many kings are there in deck? Right, because that's our n number. That's what goes in front. So there's 4. So 4 choose 3. Now for our queen. Do that again. All right, so for our queens, we have to choose 4. You know, I'm going to do it all the way through. 2, 2. So the number you're picking, right, is always your R number. So it's going to be the back number. And there are 4 queens. And there are 4 7s. And there are 4 2s. So 4 choose 3 times 4 choose 4 times 4 choose 2 times 4 choose 2. So way big difference. Part of that is because on these ones you had 13 to choose from. So you're going to have a lot more options. Whereas these ones where we are picking, those are suits. The numbers, I don't know what you call that. It's the opposite of suits, but there's groups of 4 of them. It's going to be smaller. All right, so this one says 4 aces. Yeah. How's that going to work? Well, we need 13 cards altogether. So I need my 4 aces. And I'm going to do this. I'm just going to label it as the rest of the cards. Because again, you got to make it a hand of 13. So there are 4 aces to choose from. And we want all 4. Now, let's do some thinking here. If we need 13 cards in total, and I already have 4 picked, so 13 minus 4 should be 9. So whatever this is, it's going to be 9. Let's up in there. So 13 minus 4. This is my hand. This is my aces. That's the rest of the cards. So here, how many do we have to pick from? Well, we've already picked out. Start again. I'm going to do it over here too. There's 52 cards in a deck. We've already used up the 4 aces. We're going to fundamental counting principle. Let's say we pick those first. So we're going to subtract 4 aces, all cards. So that should leave us with 48 left. So after we pull out those 4 aces, there's going to be 48 cards left. So that's what's going to go here. You don't have to show me this. Let me move it over when you guys are doing it, but you know what? It doesn't hurt. Again, if you're looking at it later, you might look at this and go, well, I get this part, but where did all this stuff come from? Are you sure that what you do today, you're going to remember in June? That's a couple, oh, sorry, in May. It's a couple of months from now, maybe 3, not sure. So it's always worth it. So 4, choose 4 times 48, choose 9. Oh, goodness. I have not left myself enough room. So 1, 6, 7, 7, 106, 640. So 1,677,106,640 different hands will contain those 4 aces. All right. I'm just going to apologize now. I really wish when I printed this, I had left myself some more. Okay. So notice last one. It seems pretty weird. I guess I should have said exactly 4 aces here, but exactly 3 aces and 4 kings. And then it exactly, and then we start So these ones are going to be a little bit different than these ones because it's not more than. And because you're clever, if you look at the question, see how for F, there's a lot more space. That usually means there's a lot more work. It's one of those things you get used to. Anyway, back to my aces. And kings. Now, there's supposed to be 13 cards, right? So I have 3 aces and 4 kings. I still need the rest of the card. I need some more cards. So I need 3 aces. So choose. Oh, these are all choose. Put the C's in. There are 4 aces in my deck. I need to choose 3. How many kings? Yes. There's 4 kings. And I got to choose all 4 of them. Now I got to think hard. So the rest of the cards, let's see. I'm going to run a room. I'll push it over here. Do that, yeah. So 52 cards. I've used up 3 aces. Right, remember, fundamental counting principle. You want to look at taking out your restrictions first. So we've taken out 3 of the aces, and we've taken out 4 kings. Now, don't judge me. 2 minus 7. That means there are 45 cards left. And I'm supposed to have a hand of 13, and I've already used 7. 13 minus 7, that better be 6 today. All right, there we go. So you got to make sure that you're always getting 13 here. So let's see. There we go. Let me see. Yeah. 4 choose 3 times 4 choose 4 times 45 choose. All right, so that gives me 32,580,240 different hands of 13 cards will contain exactly 3 aces and 4 kings. You know, just for fun, I want to think about, I'm making up my own question now. I'm going to put it up here. No restriction. How many different 13 card hands can I have? Well, how many cards in a deck? 52. And we're going to choose 13. So I don't care if it's diamonds, clubs, and hearts, or it's 4 aces, or it's exactly 10 clubs. I don't care. It's just how many different ways, how many different 13 card hands can I get? I bet this is going to be a super big number. Oh, yes. 6.35 times 10 to the 11. So that means 635 and then 9 zeros. Well, I could have copied all that, but basically 9 zeros after it. I only did that because I want to make sure, like this number that was over 1 billion was kind of weirding me out a little bit. It seems pretty big, but we're okay. Because I'm just going to write this out. 6, hold on. 2, 5, 0, 1, 3, 5, 5, 9, 6, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. Hundreds, thousands, millions. So 635 billion different hands that could come up. So now, for example, this answer down here, it had 1 billion in it. That's hardly anything. It's like 1 out of 635, so it's no worries at all. All right, back to the question. This one's pretty straightforward. Exactly 10 clubs, you should be able to do that by now. So we need to do our clubs, and then we're going to have, there's some cards. So there are 13 clubs. I need to choose 10. And then, let's see, I need 13 cards altogether. I already got 10, so that's better be a 3 there. And my number here, there was, oh, that's why this is exactly 10 clubs. All right, I had to be careful here. I was almost going to put something else like 42 or something, but because it says exactly 10 clubs, I can't have any more clubs show up later. So when I go to pick the rest of my cards, I got it. Let me explain it this way. I have my deck of cards. I pull out exactly 10 clubs. Okay. Now, when I go to pull the other 3 cards I need, I also have to take out the rest of my clubs because I can't have another club. I can't have 11 or 12 or 13 clubs. Yes. So watch for the word exactly. That's going to be tricky for you. $13, 10 times, excuse me, 39, 3, 2,613,754. Okay. That way. Not more than 10 clubs. So that is always not more than, not less than, this many are equal to. Inequalities always cause grief. So let's just hold on. Let me get some paper. It's going to take some room. All right. So this is C22. Sorry. 1F. So we are going to do this, I think, in 2 different ways. And I'll fess up. One's going to be slightly easier than the other one, but we'll do it both ways just so you can see. Again, that not more than is what reminds me I have to be careful. And honestly, the extra space it left. We're going to have to do this by cases. Okay. So this is what my brain says. Let's look at the possible hands. I'm dealing out some cards. I could have 0 clubs in my hand. Now, 0 clubs, does that fit this? Not more than 10. Yes. Okay, what else could I have? I have 1 club. That still works. Okay, I'm going to pause. My dog is having a crisis. And I want you to figure out what else I'm going to keep writing. Okay, in case you're hearing some rattling in the background. Oh, she's disappeared on me. I mean, I thought I would show you my dear sweet jelly bean just got a new toy. It's a giant tennis ball, and she's trying to figure out what to do with it. Back to math. Okay, so our question said, you cannot have more than 10 clubs. So what I did, well, so when I turned it off, is I wrote out all our possibilities. So if there's 13 cards in hand. That's what the original question said, right? Way back there at the very top. It says a game of cards, each person is dealt 13 cards. So if I am dealt 13 cards, these are all my possibilities. I could have no clubs, I could have one, all the way down to 13 clubs, right? Okay. Now, the question says not more than 10 clubs in my hand. So 0 is not more than 10. So is 1. So this is good. This is good. All the way down, 9. I'm just skipping here. So these are all just fine. So 6 is not more than 10. Now, is 10 not more than 10? Yes, actually it is, right? Because 10 is still okay. But 11 is no good because it says not more than 10 clubs. So this is no and no and no. These ones are no good. Okay, well, I need to do one more thing. Excuse me. I still need 13 cards in my hand. So if I have 0 clubs, that means I need 13 other cards. Yes? Okay, cool. If I have 1 club, how many other cards do I need? I have 1 club. I have to have a grand total of 13. So that should be 12 other. If I have 2 clubs, that should mean I would need 11 other. And I suspect you're clever and you're already seeing the pattern here. Let's see if it works. 10, 9. Okay, cool. I'm gonna double check at the end. So if I have 13, didn't have to go that far, but I did anyway. If I have 13 clubs in my hand, I don't need any other one to give me a grand total of 15. I should say this is if I have a long question like this, like each of these is individual cases, I will tend to do the same step over and over again rather than doing one complete line and then starting over. I don't know if that makes sense. But rather than going this one, this one, this one, this one, it's just like, nope, but that's just mine. And it's bugging me, but I'm too lazy to write the word over. Okay, so now I know what each of those hands has to consist of. And I should say we had to do this because if I have a hand that has 0 clubs, 13 other cards, I can't have this and 1 club and 12 other cards at the same time. So these are mutually exclusive cases. Remember how that works, right? So when we're all done, we're just going to add up everything. We're not going to multiply stuff through once we get the totals for each one of these lines. So let's set this up. So I'm going to do it this way. Unlike my usual draw the line, put stuff underneath, I don't have enough room. So 0 clubs. So that's going to be, there's 13 clubs and I'm going to choose 0. Okay. You know what? I am going to do this. 13, choose 1. So I'm just going to I'm going to do all the clubs all the way through. And I bet you could probably even pause the video and write it out yourself. Whoops, I'm going to stop there because we don't need 11, 12, and 13 for right now. Okay, so there's going to be all my clubs. Now the other cards. So I'm going to need exactly 0 clubs. So that means this other part, no clubs in there. So if I have a full deck of cards and I take out all the clubs, how many are left? 39. Choose, in this case, it's going to be 13. And my process is going to be the same here. Every single time, I'm going to be using 39 cards because I need exactly 1 club in there. So I can't have clubs as part of this. And again, we're seeing that pattern. 39, choose 11. And I'm just going to see if this makes sense. So if you look, the number of cards I'm choosing 10 clubs and 3 other ones, and 9 clubs and 4 other ones. So you can see the choosing numbers, they add up to 13, which makes sense because there's supposed to be 13 cards in our hand. For those of you that are going, wow, no, I'm not going to give you this question on the test. I probably should have said not more than 2 spades or something much smaller. But it's good practice. Practice now so that when you get something similar on the test, not so scary. Anyway, let's go. 13, oopsies, 1, 13, choose 0 times 39, choose 13. Uh-oh. I was afraid of that. I don't have. I guess I'm going to squish. Okay, so it already flipped over to scientific notation, so I guess I will have enough room to write stuff. But remember, you've got little times 10 there. That's this part. And then this exponent is that one right there. 13, 2. And I'm just going to go down this. But I will say right now, we're going to do the question 2 different ways. I suspect there's going to be a little bit of a difference because every time I do this, I'm rounding a little bit because I don't want to write all the numbers out. You only get to do that when it flips over to scientific notation on you. I'm going 2 decimal places. Going 5 to, yep. All right, 13, 5. Oh, and now it flipped back out of scientific notation. So I got to write small again. Have I mentioned I would not do this to you on the test? In the old days, when I was in school, we didn't have fancy combination button. A lot of times teachers would allow us to just write this part out and not actually do the final calculation, because if we had this, then it was just a matter of, it's almost busy work. That's what I'm feeling I'm doing right. It's almost busy work because there's been so many examples. Times. Oh. Enough. Hey. That's what happens when your dog barks in the middle. Okay, so now what I'm gonna do, and I'm gonna do it off camera, I'm gonna pause, is I'm gonna type all this back in and I'm gonna add it up. But I will just show you how to put in that number first. Okay, so 8, 1, 2, plus 5.08. Now on my calculator, it's a little button that looks like, it's called a caret key. Looks like a little house or a little teepee. And that will give, hold on. That is not the button I'm going to use. That's my exponent button. I need that one. Often there's a times 10 button. Good thing I didn't screw that up. So on this one, see how it says E10? So that means to the 10th power. Okay, anyway, I'm going to pause this, add this all up, and then come back. Okay, well, that worked out to be swell. What I discovered is my calculator does not want to add up that many numbers in a row, and it all got messed up. So I am going to do it again later, and I will put an answer in here. But like I said, this was a really, where I should have said, hey, just set it up. Don't bother calculating the final answer. But if you remember when we started this, I said there was 2 possible ways to do this. Okay, so plan 2, which is what I'm actually going to use as an answer. Oh, by the way, I'm going to take this, I'm going to put it in a spreadsheet, and it'll add it up for me. The other way to do this is using the complement. Okay, not more than 10 clubs. Well, why not figure out this part? And then we're going to figure out how many hands are possible, subtract this, and get the complement, which is this part. So these are all the hands that have more than 10 cards. So let me just draw the picture. All our hands. This number is going to be 10. Nope, not 10, because 10's here. It will be more than 10. Which translates to 11 clubs or 12 clubs or 13 clubs. That means this section out here, the complement is going to be not more than 10. And I think it's going to be a lot easier to figure out. Okay, so This is plan 2, plan B, because plan A wasn't the greatest. Okay, let's get back at this. So this is plan B. And we're gonna figure out how many hands you can have in total. Then we're gonna have calculate the ones that have more than 10 clubs, which I have set up here. And then we're just gonna do a little subtraction. It's gonna be much better. So again, using the complement. So all the different hands that we can have, there are, actually calculated that earlier today, 52, and we're gonna choose 13. All right, so 6.35 times 10 to the 11. Now we're gonna do these three. 11 clubs. Clubs. 13 clubs. Two other. One other. And 0. So it's just going to be following the pattern that we used up here. 13 choose 11. 13 choose 12. 13 choose 15. And then what did we use? We had 30 over here. We had 39 for everything because that's all the cards that are not clubs. So this is going to be 39, 2, 39, choose 1, 39, 0. Time, 39, 2. Oh, this is much nicer, isn't it? 9, 6, 13, choose 12, times 39, choose 1, and 13. I know what the answer to this is. I think it's 1 times 59, choose 0. Because there's only one hand that's going to have all 13 clubs in it and nothing else. So we're going to take this one. Oh, let's add those up first. 9, 6, 3, plus 2, plus 1, 0, 1. Okay, we're going to subtract 0, 1. I'm not sure what my calculator is going to do. I can tell you right now, if I type this in like this and subtract that, I'm not going to, you're just going to get the exact same answer. So 52, choose 13, subtract 10141. Still get the same answer, which is basically saying there's so many hands. This is just such a small number, we don't even notice it. Okay, I'm really sorry about that answer. And the reason again is coming in too small. Difference on calculator. I think if you guys did it on your phone, you might carry more decimal places and you might actually see it. But remember, we figured out that this was, if this was money, this was like 635 billion. And if you have $635 billion and you give away 10,000, you're probably just going to say you still have 635 billion. Okay, so that was a fun question. It was kind of crazy. And I will fess up, if I had known that this was this easy and this short compared to this, I would have done this as a plan A and then said, yeah, you know, plan B kind of works like I would have flipped. You never know. Okay. We're still not done. I think there's still more questions. All right, so let's put an answer on here. 6.35 times 10 to the 11. Hey, less than 4 clubs. We should be able to figure this out. Want to try it? Bet you can do it on your own. Set it up. So 0 clubs would work. 1 club, 2 club, 3 club. This is a more reasonable question. And not only that, but you know what? We have this stuff right here. Let's put it on here so it looks good. So that's going to be 13, choose 0, and times 39, choose 13. And this is going to be 13, choose 1. So this is my clubs. And then the rest of the cards, 39, choose 12. So it's got to be 13 cards altogether. 13, choose 2. I like this better. 13, choose 3. Right, because it has to be less than. See, this was not more than 10, so 10 was included. It has to be less than 11, 9, 10. Okay. And again, this is in cases. So we have to work out each one individually and then add them up. And I'm going to be lazy because the numbers are right here. But I want to see if I can do this on my calculator. I should be able to, if I'm careful. 13, choose 0, times 39, choose 13, plus, so I type that in, I'm going to put plus this, 13, choose 1, times 39, choose 12. Now I have to go plus because I'm going down to the next 9, 13, choose 2, times 39, 11, and the last one, plus 39, choose 10, times 13. Did that one backwards, but it's okay because that part's multiplying. So there, woohoo, is our final answer. 3.715 times 10 to the 11. Now, I'm very curious. I'm going to add up these. So I want these 3 numbers. Let's see if we're close. 8, 1, 2, 2, 4. So can't even see me doing that. 4, 2, 5, 4, 4, 4, plus 5.08, 10, plus 1.31, x 11, 1.8. And we get 3.71. No, it's slightly different. But if I rounded to 2 decimal places, it would be exactly the same. And the reason it's not the same is because when I was writing these out, that part number there, like the second decimal place, I was rounding all the time. So it's not surprising that this is going to be slightly. When I typed that all into the calculator, it came up. Okay, those are two scary questions. Let's do this one. It's easier. Okay. 4 and 3 is 7 and 2. Oh, sneaky question. Remember, we're supposed to have 13 cards. So hearts, diamonds, spades. There. So there are 13 hearts, and I need to choose 4. And there are 13 diamonds, and I need to choose 3. And there are 13 spades, and I need to choose 5. Now, notice it doesn't say exactly. So once I take these guys out, that last card, because there is only 12 here, it doesn't matter if it's a heart, a diamond, or spade. It doesn't have to be a club or anything. It doesn't say exactly. So if I had 52 cards and I took away 12, right? Because we took those ones out first, that's going to leave us with 41. Oh well. Let's do that. 13 choose 4 times 13 times 13 choose 5 times 40 1. All right, so 1.05 10 to 10. Now this was key here. And now you have to arrange them. So this one, I'm going to have to multiply by, once I picked my cards, then it's how am I going to arrange them? Now, how many cards were there? 13. How many ways can we reach 13 cards? What's 13 factorial? So I'm just going to leave that on my calculator and I go times 13 factorial. All right, so final answer. Oops. 6.56 times 10 to the 19. That was, okay, that question was much easier than the previous two. All right, so be careful with cards when you're seeing less than or not more than or something like that. Be really careful, but the rest of it, excuse me, is pretty straightforward. Watching for when you see arranged, because if it says arranged, then you got to permute at the end. All right, thanks for being patient to that video.